Hi, this is the oral submission for the problem set 8, and the study being focused on today is a study with regards to which seeks to investigate the relationship between humidity, temperature, and the number of COVID cases in Bangladesh. And yes, the objective is to determine whether humidity and temperature do in fact have a correlation with COVID transmission, and whether there's an association between humidity, temperature, and COVID transmission. And so, in order to investigate this hypothesis, the method used is first they have extracted data from the Institute of Epidemiology in Dhaka, which essentially has collected data from daily testing and based on whether these are on daily PCR tests and whether these are positive or negative tests. And so they have data on daily testing going on in Bangladesh. Um, yeah, and so that's where they get the data of number of COVID cases. And of course, when it comes to humidity and temperature, they look at respective meteorological agencies to determine the data from there. Yeah, the data essentially comes from the Bangladesh Meteorological Department. And so after they've collected that data, what they seek to do is determine the association using a multiple linear regression, wherein they believe that the correlation between these humidity, temperature, and cold transmission is linear and not non-linear. And of course, instead of um, finding the relationship in standalone, the authors believe that humidity and temperature both influence um, the number of COVID cases in a big way, and therefore putting both of them together will make the model more accurate. That's the hypothesis at least. And of course, so humidity and temperature are two numerical variables used, and the dependent variable is number of COVID cases. And of the humidity and temperature are the two predictor variables, and the third predictor, which is another numerical variable, it's the number of tests, just to give an idea of the number of tests, the number of testing each day, and the possible number of real cases that are being transmitted as opposed to whatever is being tested. And so, of course, a regression estimates are produced. And so, when it comes to the results received by the authors, on one hand, they essentially have a bar plot wherein they have several temperature readings and humidity readings inserted as categorical variables, and the respective number of COVID cases during that temperature region is calculated. And therefore, based on that data, there is a clear downward trend in number of COVID cases as the temperature increases and as the humidity increases. And so it's kind of like a right skew almost, if we were to use that term. Yeah, and so there's a clear relationship seen as per the bar plot, and so that kind of hints at through a descriptive statistical approach that it may be true. And when it comes to the regression estimates, that the coefficient of regression for temperature is 11.76, while for humidity it's 8.79. So this suggests that there is for per unit increase in temperature and humidity, there's you can say COVID cases increased by 11, changed by 11.76 and 8.79. And so this is a significant difference in COVID cases as temperature and humidity increase. And so this in standalone suggests that there is indeed a significant relationship between the two. Now, of course, if we were to determine this, um, if these associations made sense, in order to be essentially the regression analysis approach conducts an inference test wherein we infer a null hypothesis is that there is no association between these two variables and number of cases. And of course, based on the p-values we receive, for temperature it's 0.038 and for humidity it's 0.005, which suggests that there is strong evidence against the null hypothesis that there is no association between temperature and number of cases and humidity and number of cases. So this means that there is indeed an association, and not just any kind of association. There is um, significant association, as suggested by the regression coefficients there. So by that token, the conclusion we can come to is during the summer and rainy seasons, when temperature and humidity are high, there will no doubt be an impact on, and there will no doubt reduce number of COVID cases, but it won't deplete completely remove it because the transmission rates are quite high, and so therefore they still might persist even during summer and rainy season. That therefore won't completely eliminate it. Although some limitations that should be stated are one, there are multiple other variables not mentioned that could very well influence the results here. That includes the population and other factors, um, yeah, such as reproductive numbers, fertility ratio, population endurance, etc., which might limit the finding. But overall, there is a relationship or association that has been determined by this study.